Okay, so now with our functions, we've looked at sketching both logarithmic and exponential functions. We've looked at the algebra behind them, so how to solve equations, how to simplify, how to evaluate. The next thing, as I said, as we go through each set of functions, we need to perform the same types of skills for all of them. The next thing is how do we determine the rule for graphs of exponential and logarithmic functions. And we're using the same strategies we've used for any of our other functions we've looked at. One of the main things to determine if you're given a graph is first of all whether it's a log graph or whether it's an exponential graph. In this particular example, it tells us that it's an equation of this form. However, even if it doesn't, we should be able to figure out if it's a log graph or if it's an exponential graph based on where the asymptote is. So just some extra information, if we had a graph with a horizontal asymptote, if we're noticing one horizontal asymptote, that would lead us to believe that it was an exponential equation. And so therefore we would use the equation y equals ax minus b plus h, for example. Or I think we were using h and k last time, so we'll still use h and k. So we would use our exponential equation. We can figure out different parts from there. If we noticed that there was a vertical asymptote on the other hand, then we would know that it was a log equation, and so therefore we would use our log equation. So the first thing we need to do in any case is to determine what type of equation it is. Generally, they will be providing us with a bit of a clue, because we've got no real way of knowing if it should have a base of e for an exponential one, for example, or of 2 or of 10. We can't really tell that just from the graph. We would need a lot of points to try to figure that out. We don't have any clear mechanism to do that. So usually they will tell you, as per this example here, what the base is going to be, okay? Once they've done that, if they've given us the rough version of the equation as they've done here, the rest of it is really quite straightforward. We've got two values that we need to find. Oops, I've missed one, haven't I? Find the values of a, b and b. So we do need an a value as well. So if you could just adjust your own sheet so that this equation says y equals a log e x plus b plus capital B. So if you could make that adjustment, that would be lovely. So we're wanting to find these things. Now we don't actually have 3 points, we've only got 2 points given. Our other is the equation of an asymptote, but we can use that as well. Remember, the asymptote is usually in our standard y equals log e function, the asymptote is just at x equals 0. Because it's not in this case, this means it's been translated. So we can see straight away that this has been translated by 1 unit to the left, or in the negative x direction, which means that what we need here, this part within the brackets here, x plus b, our x plus b there needs to be equal to -1. I'm sorry, this really, looking at where it is, let's write this should be x equals -1. That makes much more sense than trying to say equal to 1, which doesn't actually work with what we're looking at. So what we're getting here is that this would be y equals a log e. If this needs to be equal to -1, that means for that to occur, our x value here, when we set it equal to 0, we're going to get an answer of x is -1. That means going backwards, that the value of b would be +1. So we would get x plus 1 plus capital B. Okay. Now, the next thing, we need to figure out other values, our values of a, capital A and capital B. Luckily, we've got 2 points given here. It's up to you which you choose to substitute in first. Generally, it's easier to substitute in when x is 0, so let's try that option first. If I substitute in the point 0, 5, I will get 5 where the y value is equals a log e of 0 plus 1 is 1 plus b. Remember our log laws. Log of 1 is always equal to 0. So that means therefore I have a times 0, which is 0. So this whole term will disappear. And I will be left with 5 equals b. So we've now got our value of b up here we found was positive 1. Our value of lowercase b here we have is 5. Now we can find our last part by substituting in our other point to 0. So when y is equal to 0, instead of a, that's what we don't know, log e of x plus 1 is our new equation, but our x value is 2, so we will have 2 plus 1, and plus b, well, our b value we figured out before was 5. So if we are solving this, we can subtract 5. Negative 5 equals a log e of 3. Continuing on, we're wanting to find the value of a, so a will equal negative 5 over log e of 3. Okay, so we have our values. So we've worked out the first part, find the values of capital A, capital B, and lowercase b. We've done that. B equals negative 1, capital B equals 5, A equals negative 5 on log e of 3. Remember, when you are not told otherwise, we leave values in exact form. We don't work them out as decimals unless the question specifically tells us to. So we need to somehow put these together to create our actual equation. So I am going to have to rub out this here, so sorry about that. Hopefully you've got it yourself. When we substitute these values in, therefore our final equation would be y equals, instead of a, I have negative 5 on log e of 3, then I have log e of x plus 1 plus 5. Okay, so we've got our final equation there. Unfortunately, we can't work this out any better than that. We're unable to simplify it either, so that messy looking final equation is our final answer. I'm not going to spend too many times doing lots of examples here because it is the same process that we've done time and time again. You look for key features using things like asymptotes to start with. To substitute in values is a great place to start, and then we substitute in the values of any points we have to find any remaining pronumerals. So having said that, you have a try of the relevant exercise. We will go through this in class as well, do a few more examples, and give you some time to work through this. Okay, thank you very much, and that is all you need to know right now for how to determine the rule for the graphs of exponential and logarithmic functions.